All right, well, welcome everyone to our weekly Wednesday webinar series. For your Con Ed, make sure you watch the entire session, take the survey that pops up at the end. The same survey will be sent to you through email an hour later. And so if you've already taken it, don't take it again. And even if you don't need CEUs, we definitely appreciate all of your feedback to help make our sessions better. And next week, we're going to be doing the basics of HVAC sizing for low load homes with some ACA folks. And then the following week, we don't have it up here yet we're going to be doing another session, and then introduction to the International Green Construction Code. And then on June 12th, we're going to be talking with an author about how he turned his home net zero and made money doing it. Also, make sure you check out our membership if you support our mission, don't want to register for each course, want to get instant access, as well as discounts on paid courses, both online and in person, and discounts on green building certifications. Make sure to check that out. And then a huge thanks to our sponsor for this session, Niagara Conservation. Niagara, it's no surprise that toilets are the #1 cause of high water bills, and yet savings are only a simple flush away. The Niagara Conservation has answered the call by developing the world's #1 saving toilet for water using advanced vacuum-assisted technology. That's right, that's vacuum-assisted and not pressure-assisted. We personally, GHI, has glowing reviews from multifamily affordable housing renovation specialists who only spec these toilets because of their durability and cost savings both to their operations and the tenants. Now, you know it's going to work in any situation, and it'll work in these. Bonus, these are ADA approved models that are available as well to help with accessibility. So how low can you go? The stuff is 0.8 gallons per flush, single flush, and if you don't want to deal with the hassle of 2 confusing buttons. They do also have the Nano, which is dual flush and goes down to 0.5 gallons per flush for those who really want to cut out the water bills. Also, check out the Niagara Earth shower head for 1.25 gallons per minute without sacrificing comfort, and the very affordable 1.5 gallon per minute aerators that can be installed immediately today. And all of these are WaterSense certified. So check out the Niagara Conservation today for your next project. And thanks to our second tier sponsor, Build Equinox, now featuring the Serve 2. Build Equinox is a system that is a smart ventilator that detects indoor air pollution and then ramps up to exhaust it through an energy efficient mean, capturing waste heat, kind of like an ERV or HRV. The device also has an integrated heat pump system for heating and cooling, and it's design built all within the US and 100% solar powered facility. Check that out at buildingequinox.com. All right, so welcome to introduction to the new RESNET HERS H2O program. This course is approved for 1 hour in continuing education units GBCI, AIBD, NARI Green, Certified Green Professional, and BPI non-whole house. It's also approved for the Health, Welfare, and Safety HSW AIA, which may make it applicable to your state-based design or contractor license. Today, I'll be your moderator. My name is Brett Little, and I am the executive director here at the nonprofit Green Home Institute. And what we're going to be talking about today is what we think is the future. Just like we've gotten energy performance, like the HERS rating, down to a science. We know that it works. We know that it can predict energy savings and utility bills. The future now is water performance rating, where we have new homes and existing homes underway where we can help with your clients predict their water bills. And so that's kind of what we're going to be talking about today. And I'm excited to introduce our speaker, Ryan Meredith. He has 13 years of experience in energy and water efficiency, energy policy, and building energy codes, and has published more than 24 case studies, reports, and resources on those topics. As a program director for RESNET, Ryan currently leads numerous programs, including implementation of RESNET's HERS H2O whole house water efficiency standard, as well as initiatives to get energy and water efficiency valued in the real estate transaction process. Ryan holds a bachelor's degree in architecture from the Savannah College of Art and Design and lives in upstate New York with his wife and their three children. So with that, Ryan, I will pass it off to you and you can take it away. Thank you.
Welcome to today's webinar. Thanks for joining. I hope that you will learn something about HERS H2O and water efficiency during today's webinar. So for those of you who don't know who RESNET is or what RESNET is an industry-based not-for-profit organization founded in 1995. And we also are a standards making body. We write standards for energy and now water efficiency, and we also are an ANSI accredited standards development organization. We also created and we currently maintain the mortgage industry national home energy rating system standards, or referred to as MINHERS. That is the basis for HERS ratings. And we also set the standards for certification of home energy raters and also the quality assurance oversight of HERS ratings. So back in 2015, when the RESNET board first approved HERS H2O, there were three things that they really set forth in terms of guidance to staff and the committees that would be working and developing the HERS H2O standard. The first was that it had to leverage the advances that were made within the HERS standard. And more specifically, we're referring to Appendix A to the 2014 Standard 301. So Standard 301 is the ANSI standard by which the HERS ratings are based, referred to as the Energy Rating Index. It's also referenced in the 2015 and 2018 International Energy Conservation Codes. And there was a lot of work done to understand the water use in the home in order to predict energy use based on the amount of hot water being used. So a lot of work went into that, and the idea was to build off of the research that was started for Appendix A and build it to a full whole house water rating standard. It also had to be in line with the existing HERS methodology. In other words, it had to generate a score by comparing a rated home to a reference home. And that reference home needed to be representative of new construction around 2006, because that's what HERS uses as the reference home as well. So we wanted to maintain a consistent reference home of around 2006 construction practices. It also had to provide a low bar for participation. Now, that doesn't mean it had to be easy. I mean, it's an asset rating just like the HERS index, but we wanted it to be something that could be added to a HERS rating for a fairly reasonable cost by a builder. There were a number of key objectives for HERS H2O as well. It had to be applicable nationwide, as the HERS index is. It also had to be suitable for both new and existing homes, and it had to encompass whole house water efficiency, meaning both indoor and outdoor water efficiency usage. And then it had to be something that was practical and affordable to administer. So we wanted this to be a program that a HERS rater with relatively little training could take and start offering to their builder clients to do water efficiency ratings on top of the energy ratings that they're already getting. And then the scores had to be similar to the way that the HERS index functions. They had to be usable for quantitative comparison. So in the case of the HERS index, a score of 100 is the reference home. The lower the score, the more energy it saves. The same for HERS H2O. 100 is the reference home, and the lower the score, the less water the home uses. So I want to walk you through a brief timeline of the development. So as I mentioned, in 2015, the RESNET board approved the HERS H2O program. In 2016, we formed a large working group and a number of technical subcommittees that were underneath that working group. And then the initial work got started. But it was really 2017 when the bulk of the work went into developing the technical guidelines. The technical guidelines were drafted. They were put out for public comment. We also had two of the subcommittees. One of them developed an inspection checklist. The other developed an inspection guidance document. And then we actually formed the standard development committee known as SDC 1100 near the end of 2017. And then we also worked with some builders to do some very initial field testing to take the technical guidelines. Let's see what it looks like when we implement them in the field, and make corrections as necessary before the ANSI process started. In 2018, the HERS H2O guidelines were approved by the RESNET board. That was in February of 2018. And then the real development began on the water rating index, which is known as Standard 1101. That got off the ground. The Standard Development Committee reviewed the initial draft. There was a public comment period, and then we also began developing the implementation standard. So the actual technical standard is one thing, but then RESNET as the program implementer for HERS H2O, we had to also begin developing quality assurance standards. How are we going to capture the water usage data within our RESNET registry, and also what type of training was going to be needed for raters. So then that brings us to now in 2019. We've gone out for a second round of public comments. Actually, that round of public comments ended at the end of April. We also, based on the pilot study that happened from June through December of 2018, we made some revisions to the inspection checklist and the inspection guidance document, and we're in the process now of developing the training and finalizing the implementation standards. And then later this year, we expect to publish Standard 1101 as a final standard, and also launch the entire HERS H2O program nationally. The goal is to do that by October. So the development process, as I mentioned, we had to, if you're familiar or not with the ANSI standard process, you have to, in order to develop an ANSI standard, you first have to have some document of technical guidelines that will serve as the basis of the standard. So those HERS H2O technical guidelines served as the basis for Standard 1101, which is an ANSI standard. And then once that standard is completed, it could be referenced in codes, it could be referenced in other standards, it could be adopted by local jurisdictions or states. But that's generally the process that an ANSI standard takes. And then we will maintain that process and do a full review of the standard every 5 years. So you might be wondering, what is the difference between the Standard 1101 and HERS H2O? How do they relate? So Standard 1101 is developed through the full ANSI consensus-based process. It is overseen by the Standard Development Committee 1100, and there is also a technical subcommittee that provides recommendations to the Standard Development Committee, and the technical subcommittee reviews a lot of is primarily responsible for reviewing public comments and then providing a recommendation back to the SDC on how they should respond to those comments and what changes should be made to the draft standard. The HERS H2O is a RESNET specific program. So the technical components of HERS H2O will actually be based on Standard 1101. But then, because RESNET is the implementing body, we have to also have some additional program requirements, and that includes things like certification of raters. What type of training does a rater have to go to be certified to do the HERS H2O ratings? Accreditation of rating providers. RESNET has a network of about 100 rating providers that are responsible for certifying HERS raters, training HERS raters, and also providing quality assurance on HERS ratings. So what type of requirements do we need to accredit rating providers for HERS H2O? And then what should the quality assurance requirements look like for water as opposed to energy? And then finally, approval of software, what's going to be required in order for RESNET accredited software to offer a HERS H2O rating on top of a HERS rating. So quickly, I'm going to go through an update on Standard 1101. So we had in the summer and fall of 2018 was the first public comment period. PDS stands for Preliminary Draft Standard. In the spring of 2019, as I mentioned, we just wrapped up the second public comment period on the second preliminary draft. And the subcommittee actually met just last week to review those comments and provide recommended responses to the SDC. The SDC still has to review those responses and vote via electronic ballot on the changes to the standard. Most likely we'll have to go out for one more round of public comments, which will be limited just to the changes that were made to the standard, and we expect to publish that standard later this year. So now I want to get more deeply into HERS H2O, why is there a need for water efficiency standard in order to rate a home for water efficiency, and what are the components of the HERS H2O rating? First of all, drought is not the only driver for water efficiency, and this is one of the maps. This is from back in August of 2018. You can see there are certainly in the Southwest some very dry conditions, but those dry conditions are not the only driver. Certainly, water scarcity and drought often create an immediate need for implementing some water restrictions or some type of water efficiency incentives to reduce water consumption. But for many parts of the country, it's water infrastructure that is the need to upgrade and replace aging water infrastructure is what's leading to significant increases in water costs. Now, this is from 2000 to 2012, and you can see these are the top 10 metro areas that had that had the highest increases in water costs. And as you can see from the list, some of them are certainly not in areas where they have significant droughts, but these costs are just a factor of aging water infrastructure and the need to upgrade that, and inevitably some of that cost has to get passed on to the water customers, and therefore costs go up. So that means even in those cities where you might think, wow, we don't really have any water issues, water efficiency is not that popular because we don't have any water restrictions. Well, there's still going to be significant opportunity for cost savings in those areas where water prices are going up because water infrastructure is aging and needs to be replaced. I like to show this slide to kind of ground this concept of a rating. There's often confusion around what is the rating, and I've noticed that especially when it comes to the HERS H2O. There's been a lot of confusion around the reference home and the rated home. So I provide this as a basic overview. So the reference home is automatically generated by software. Now, currently there's the RESNET HERS software does not include HERS H2O. We expect to engage the software providers for HERS software to start providing HERS H2O within their software this month. So the reference home is automatically generated by the software. It establishes the baseline by which the rated home is compared to, and it's generally based on 2006 construction practices, and it will score a 100 on the HERS H2O scale. Now, the rated home is the home either as it is built or as it is rated based on plans, and the components are entered in by the rater. Each component that's more efficient than the reference home is going to reduce your water use and reduce your index score, and any component that is less efficient than the reference home is going to do the opposite. It's going to increase your index score and increase your water use. It's also important to understand the scope of this standard. If you're familiar with the HERS index, you know that the HERS index accounts for both single family and multifamily construction, and specifically multifamily construction of any height. The HERS H2O standard is currently limited only to 1 and 2 family dwellings, and the primary reason for that was that there wasn't enough water usage data in the multifamily sector for us to be able to develop the equations that go into the calculations for estimating water use. So currently the scope of the standard is just for 1 and 2 family dwellings. It does not include multifamily. So most of these are probably not very surprising, as you can see in terms of the components for the water rating. Your showers, kitchen faucet usage, lavatory faucets, clothes washers, toilets, water softeners. It also accounts for leaks or other water use that's not generally specify within the data set that we use to create the standard. It also accounts for excess water pressure if there is excess water pressure at the home, irrigation systems, and then whether or not there is a pool or a spa present at the home. There's a number of other factors that also go into the rating. So that the size of the house, the square footage of the house is one of those factors, as well as the geographic location. So I'll show you a little bit later how much the geographic location can impact the amount of water use, and also whether or not you need to target indoor or outdoor water use for improvements in terms of reducing your index score. Plays a big role. The number of bedrooms is used as a surrogate for estimated number of occupants. We also take into account the lot and the landscape size, and I'll get into a little more detail in terms of how that's calculated and what gets accounted for when you're talking about outdoor water use and irrigation. We also take into account the hot water distribution layout. Is it an efficient short runs, or is it a long distance from your hot water heater to your furthest hot water consuming fixture? And then whether or not there's hot water pipe insulation as well. And also wanted to make a note about rainwater and gray water. So rainwater and gray water are not addressed in the current version of the standard. We include an explanation for this within the foreword, both to the preliminary draft standard number 1 and preliminary draft standard number 2. Basically what it came down to, the committee decided that there was not sufficient reliable data available to quantify the impact of alternative water sources on a home's potable water use. We have requested rainwater and gray water data. We did finally, on the second round of public comments, receive an offer from a builder to share rainwater data for their homes. So we're hoping that's something we can go on to start incorporating rainwater. But what it came down to when the standard was first developed, there just wasn't enough data available to understand how rainwater or gray water should offset potable water use within a home. And so we decided to leave them out of the standard at this point. And so the HERS index, the HERS H2O index score is very similar to the way that the HERS index is calculated. Takes into account indoor and outdoor gallons per day for the rated home, and then indoor and outdoor gallons per day for the reference home. Divide those, multiply by 100, gives you your actual index number within the scale. So the rating calculation methodology, there was a lot that went into this, and I'll try to just distill it into a few bullet points. So it's, as much as possible, we used data, and the best available data that we could get on water use and 1 and 2 family dwellings. So the calculation methodology is grounded in water use data, and the reason for that is we want to be able to estimate as closely as possible the actual water use in that home. And so we have to take into account how water is, what does the data tell us about how water is used in a home in order to develop the equations that go into the methodology for calculating the HERS H2O index, and also the estimated water usage numbers that also are a part of the index. So the indoor reference home is based primarily on HERS. As I mentioned in the beginning, that's primarily the work that was done for Addendum A to the 2014 version of Standard 301, and Addendum A addresses domestic hot water. The outdoor reference home is based primarily on the residential end uses of water study, both numbers 1 and 2. And then, as I mentioned earlier, the number of bedrooms is used as a predictor of occupancy. And then in general, we use the data that went into Addendum A as the basis for starting the standard and developing the equations. So the most common question we get for HERS and now for HERS H2O is, how do I get credit? What do I have to do to get a lower score? So here's a few general things. For the indoor model, it's going to respond to more efficient plumbing products. So if you put in, efficient shower heads, if you put in the 0.8 gallons per flush toilet that Brett showed at the beginning, you're going to get credit for that. And I'll show you what some of those credits look like in a minute when I walk through some examples. If you put in more efficient appliances, so really efficient dishwasher, clothes washer, you're going to get credit for that as well. And then if you do a more efficient plumbing distribution system where your hot water heater is placed relatively close to your furthest hot water consuming fixture. And then for the outdoor model, you're going to notice that smaller landscapes, and specifically a smaller irrigated area, is going to get a significant amount of credit in most climates. It depends, and it depends on geographically where the home is located, and I'll show you how that comes into play shortly. And then more efficient irrigation technology, so you can use smart controllers, for example, weather-based controllers that detect whether or not there is enough, a soil moisture sensor to tell you that there's enough moisture in the soil, doesn't need to irrigate, as well as more efficient emitters. And there's something referred to as the Residential Irrigation Capacity Index, or RICI, which is a part of, it's an optional thing to use within the outdoor water consumption portion of the standard, and I'll explain what it is and how it's measured just a minute. So this is just a shot of our calculation spreadsheet. As I mentioned, we currently don't have the software yet for HERS H2O. So we've been working off of a spreadsheet since the beginning to get an idea of how what impacts the HERS H2O score. We've got to a point where we're just about we pretty much to a point where we can't do much more within the spreadsheet. The capabilities of Excel spreadsheets we're starting to surpass that with some of the equations that are developed, which will be much more easy to implement within software. But this is for what I have highlighted here within these blue boxes is the indoor calculation fields. So you can see the distribution system. It's asking for what type of distribution system it is. Is there a recirculation loop on it? It also asks whether or not there's hot water pipe insulation. And then you're going to input your gallons per minute for showers, for kitchen faucets, for lavatory faucets. And then if you want to get credit for actual distribution length, you would enter in your pipe length, as well as if there's a recirc loop, the length of that, and then whether or not there is a drain water heat recovery. And then on the right side, you'll see under appliances, for dishwasher and for clothes washer, is it a standard or is it an Energy Star? It'll ask, there's a drop down for each of those. For toilets, you're going to enter in the average gallons per flush for all the toilets that are installed in the home, and then whether or not there's a water softener and the gallons removed per 1,000 grains of hardness. And then we move on to outdoor water use. So outdoor water use accounts for a number of things. First of all, the lot size is the first thing to look at. So your lot size, the entire lot size is entered into the spreadsheet in square feet. And then the irrigated area, and you'll see we use somewhat interchangeably irrigated area and landscaped area. In the original HERS H2O guidelines, we called it landscaped area. After we started working on the ANSI standard, we changed that terminology to irrigated area. So you take your lot size, then you take the amount of area that you're actually irrigating, you count for the location of the home, what city and state, whether or not there's an automatic irrigation system, and then the features of the irrigation system. So does it have a weather-based controller? What are the flow rates? And then is there a swimming pool or a spa on the site as well? So I mentioned RICI earlier, the Residential Irrigation Capacity Index. So essentially what it is an index within an index. And the primary purpose of this, the real value in having this, is that it allows you to estimate irrigation use without knowledge of plantings. You'll notice in many of the green building standards, or other types of water efficiency programs, they often rely on knowledge about plantings to understand outdoor water use. So the reason that we've shifted to this RICI, which was developed by the Southern Nevada Water Authority, is that it allows for an estimate of irrigation use without having to have a specific knowledge of the types of plants. And this also goes back to the beginning of the presentation where I laid out what the objectives and what the board was putting forward in terms of guidance for us to develop the standard. We didn't want HERS raters to have to take in-depth course on understanding the types of plants that were installed. We thought that that would be very prohibitive of the standard actually being able to scale and get a lot of usage. So the RICI kind of fills that. There's a baseline which is set at a 5, and that's based on outdoor water use data. And there's a lot that goes into that, probably a 30-minute presentation on its own just to understand RICI, how it was developed, and the data that goes in behind it. So for our purposes, each 1-point reduction from that baseline is equivalent to about a 10% reduction in outdoor water use. Now, RICI is an optional method. It's not required to get a HERS H2O score, but if a builder wanted to do it, it is fairly straightforward, and I believe that with some training, raters will be able to do the test to actually determine what the flow is. I see a question about does no irrigation provide any credits? The standard has been set up in a way that if you live in a location where it's very unlikely that that you can't use any irrigation, it's not going to give you significant credits for that. So it is a somewhat complex issue, but we were trying to avoid those instances where a builder may choose to not put in any irrigation, but then the homeowner moves in and realizes they can't maintain their plants without having some amount of irrigation. And on top of that, the water use data suggests that not having an automatic irrigation system and watering with say with a hose actually uses more water than having a halfway decent irrigation system.
So there was a follow-up question about using reclaimed water, which I suspect is into the gray water realm, or is there a reclaimed opportunity?
No, that would fall under the gray water in terms of not necessarily having enough data to understand it. You're still using that water even if it is reclaimed, but we don't currently have anything within the standard that addresses reclaimed water.
And what about the use of, well, so rain barrels, I assume, would then be rainwater capture. So same deal. You don't have a way to quantify that.
That's right. Yeah. So we don't know. We don't have a way within the. What it was is we didn't have enough data to understand how much for specific locations, how much rainwater are you collecting, and how much does that offset your actual potable water use. So that's kind of where we ended up, and we've been seeking data on rainwater and on gray water, and we're actually going to be doing a pilot with a manufacturer of a gray water system and they're going to capture the data to better understand what the impact is of using that. Now, in this particular case, that the system only collects gray water from showers, and it only uses it for toilet flushing. So that at least narrows down within our standard, we know the estimate of how much shower water is going to be produced, and we know how much based on occupancy and number of bathrooms, how much water will be flushed through the toilet. So we can have an idea, then we can start to see, okay, we can capture this much water and we're going to be using it to offset the toilet water use. Therefore, we can start to calculate what the impact is on offsetting potable water use.
And then following up, there's a question, realizing that the RICI is intended to be a simplified model without having to know watering requirements of different plants, does the RICI at least take into account high water use turf versus not having, or like I guess you could say, there are turfs out there that are coming out that are, maybe only need to be watered once or twice and barely mowed. So those low water turfs.
Yes, yeah, it does. So it does take that into account, and I'll actually let me walk through the process for how we test for RICI, and I'll say that in terms of not having to know about plantings from the rater side, we do expect that the irrigation professional that's installing the system will be the one responsible for ensuring that whatever plantings are there, they're supplying the amount of water that's needed for that turf or for any plantings that are on the property. So that's kind of the way around it. But then we actually test the flow rates for all the zones, and that gets input into the calculation spreadsheet. So to test for RICI, you first determine the irrigated area. So you start with the entire lot for the home, the entire lot the home sits on. Then you subtract the footprint of the home, and you subtract any type of hardscaping that's installed, whether it's a sidewalk, a driveway, patio, whatever it may be. You subtract that from the lot area, and then you subtract any area that's not going to receive any irrigation. So like artificial turf might be an example, or you have only drought tolerant plants in one area, so you're not going to have any supplemental irrigation there. You subtract all of that from the lot area, and then to determine the irrigation flow rates, you would turn on all of the turn off all fixtures and appliances in the home. You set the irrigation controller to run each zone for a few minutes. This allows the system to equalize. And then you measure the flow rates by noting the start reading of the meter, and then watch it for 30 seconds, multiply that number by 2, and then sum together the flow rates in gallons per minute. And that number, that gallons per minute number of all the zones in the within the irrigation system gets entered into the calculation spreadsheet, and when we have software, it will be entered into the software. But it's a gallons per minute number for the flow rate of all the irrigation zones. And so the outdoor, I've highlighted in this screenshot the outdoor calculation fields. You can see in the middle on the left there the lot area in square feet, and then landscaped area in square feet. So the lot area, you took the lot area and then you subtracted everything that's not going to be irrigated from that, and that's what you would enter as your landscaped area. And then on the right side, you'll notice it asks you whether or not there's an in-ground pool, and then it asks whether or not there's an irrigation system, and this is where it toggles off either yes or no. And then there's one for smart controller. So smart controller is an optional one. You would click yes, there is a smart controller or a weather-based controller on the system. And then it asks if you want to use RICI. So you don't have to use RICI. As I mentioned, it's an optional way to lower your HERS H2O score if you're using efficient irrigation. And then you would, if you want to use RICI, you would select yes in the drop down, and then under zone flow rates below that, you would enter in the sum of all the irrigation zone flow rates. And in some cases, the irrigation installer will measure this and provide it to the builder. And in that case, the rater just needs to use what was there. If it's not provided to the builder, then the rater would go ahead and do the test that I just described. And then finally, below that red box, it asks, is there a professional audit? So if you have a professional audit done of the irrigation system, you would get some additional points. for that, and that's also an optional path as well. So I want to show some an example of the climate differences and how they can drive whether or not you need to focus on indoor or outdoor water use. So take a lot that's 5,000 square feet, a 2,400 square foot house, 3 bedrooms, 2-story home. The landscape area is 2,348 square feet, which is basically the reference landscape area, and if there's an automatic irrigation system. So when you take that data and plug it into the spreadsheet, you'll see that in Duluth, Minnesota, the annual water use for that home is about 60,000 gallons. But move that home to Phoenix, Arizona, it goes up to about 140,000 gallons annual water use. And the real difference comes in when you look at indoor water use. So in Duluth, about 80% of those 60,000 gallons is for indoor water use. But in Phoenix, only about 33% of that total water use is indoor water use. So this starts to inform that obviously in a place like Phoenix, you have to take into account outdoor water use. You have to make improvements to outdoor water use in order to lower your HERS H2O score. But in Duluth, you're definitely going to want to do indoor improvements, and then maybe some outdoor improvements as well. And because you can see here from the water savings, if you installed a WaterSense labeled plumbing product in Duluth, you're going to get about 10% savings, but in Phoenix, you're only going to see about a 4% savings because so much of that water use is outdoor irrigation. So hopefully you've all, if you're not familiar with the WaterSense program, you've at least heard of it. WaterSense is in the process of updating to version 2.0, and there's a number of mandatory requirements that are included within that proposed version 2.0. One of them is a maximum water pressure, 85 psi, and then the hot water piping is actually the same as the reference home. So in developing version 2.0 for WaterSense, they are taking into account that program like HERS H2O or other programs that allow a home to be rated based through some type of standard. They're recognizing that and looking for ways that there can be a performance option within WaterSense. So you could use HERS H2O and meet a specific target in order to obtain the WaterSense label. So that's where they're headed with it. And so what I'm doing is pulling out some of those mandatory requirements here, and I'll show you some examples in the next few slides of what the calculations do in different parts of the country in terms of influencing the HERS H2O score. So toilets for WaterSense 2.0 is 1.28 gallons per flush, kitchen faucets at 2.2, shower heads at 2 gallons per minute, and lavatory faucets considered low flow. The dishwasher and clothes washer are the same as the reference home, and the WaterSense HERS H2O assumes that there's not a water softener installed, and then the irrigation is the same as the reference home. So I'll put this into the spreadsheets to give you an idea of where things kind of shake out when it comes to influencing the HERS H2O score. So for in this case, I'm looking only at indoor water use. The target score for the WaterSense 2.0 is going to be a 70. So if you look at the locations, I've got Park City, Phoenix, Tampa, Denver, and Riverside. The first column there where it shows WaterSense requirements, this is from the previous slide. Enter into the calculation spreadsheet just those WaterSense requirements, and you can see in each of those locations it's going to come in, but somewhere between a 93 and a 96 on the index scale. But then let's go ahead and put in an Energy Star clothes washer and dishwasher, and you'll see you get a little bit of a bump down depending on location, anywhere from an 88 to a 92. Let's take that home and now let's install a 1.5 gallon per minute shower head and as well as a 1.5 gallon per minute kitchen faucet. and that drives you down even further, getting into the 70s now in Tampa, 79 to a 92. As you can see in Phoenix, that these indoor measures, because the indoor water use is such a small percentage of total water use, there's not making a big impact on the index score. So then we can look at doing toilets. Let's put in the Niagara 0.8 gallons per flush toilet into that home. Drive scores down from anywhere from a 76 to an 86. We can use an efficient hot water distribution system, and you'll see getting very close to that target score in Tampa of the target score of 70. We're at a 71, but in Phoenix still at an 83. Then we install the best available clothes washer and dishwasher, and you can see in Tampa and in Park City, we're down below that target score of 70. Now let's take a look at at outdoor water use in terms of impacting the HERS H2O. So these are the same locations. The furthest left column here. So in the previous one, I left the irrigation toggle off to say there's no irrigation. So I've taken the home that was on the furthest right of this slide, of the furthest right numbers is where I started, and then I said yes, there's irrigation, and this is what happened to the numbers from there, anywhere from a 75 to an 86. Now if we went ahead and got a professional audit and we installed a weather-based controller on that system, you can see in Park City we're again below that target of 70. In Denver we've hit the 70, and in Tampa we're below the 70 target score for WaterSense. Now if we wanted to go beyond that, we could reduce the irrigated area. So again, maybe there's artificial turf, maybe there's drought tolerant plants that don't need any supplemental irrigation, so we can further reduce the irrigated area by 20%. And in this case we're getting very close to 60 in basically every one of those locations. Now if we want to use RICI, we could use RICI as well, and let's assume 6 gallons per minute for all zones. That's for all zones on the irrigation system, 6 gallons per minute flow rate, and that gets us down to the mid 50s for basically every location. Now I want to show you a little bit something different here. This is the impact that RICI has on irrigation, just RICI. So we have a total lot size of 5,000 square feet, the reference irrigated area, which is 2,348 square feet. The indoor on the calculation spreadsheet that did this, the indoor numbers were set to the WaterSense 2.0 requirements. So you can see we started out, again, just like the first slide I showed in this series, between a 93 and a 96. Now this is looking just at outdoor water use. So the reference irrigated area and a 25% flow reduction. So that would bring us to a 25% reduction in flow would be 8.8 gallons per minute for all zones. And we drop a few points, basically 4 or 5 points, 4 to 7 points in each of those. And then if we take the reference irrigated area and a 50% flow reduction, so down to 5.9 gallons per minute for all zones, and that drops us to anywhere from an 80 to an 85. And now for the last one, let's reduce the irrigated area by 20% and also add a weather-based controller. And in this case, in Phoenix, we've actually met the 70 score. So this is basically showing you how, depending on climate, but for a place like Phoenix that has a significant amount of outdoor water use, you can see that you can focus just on your outdoor irrigation and achieve that below that 70 WaterSense target. Now I want to show a few slides that talk just about the inspection process. So overall it's a fairly simple process. We did do, as I mentioned, a pilot study from June through December. We are still in the pilot phase, and we have some raters and builders that are still using the spreadsheet to do HERS H2O ratings on their homes to see how it works, and also providing more feedback to us on implementation. So first of all, there's two inspection resources. One of them is an inspection checklist, and that checklist was originally developed by one of the technical subcommittees back in 2017. It has since been updated based on the feedback we got from the pilot study from June through December of last year. This is a screenshot. The inspection checklist is less than 2 pages in total, so there's about another half a page beyond what you see on the screen here. There's also, to complement that, there's an inspection guidance document, and this document walks through the various criteria that are listed on the inspection checklist and provides additional guidance to the rater on what they should be looking for, how certain tests should be conducted, and that kind of thing. And we expect that both of those resources will be included within the actual training for HERS H2O that will be an online training released later this summer or early fall. So some of the inspection tools likely to be required. A lot of these things are pretty basic: a stopwatch, or even just a timer on your cell phone, digital thermometer such as a digital food thermometer. I would add to that a TDS meter, especially if a rater's working in an area where there's potential to have hard water, and they want to verify that. Often those meters, they're very inexpensive, and they also typically include a thermometer function as well. A pressure gauge, a bucket or a flow bag that has the volume measures marked, so you can verify flows of your faucets and shower heads. And then dye tablets to check for any leaks in toilets, as well as a tape measure. And as I mentioned, a water hardness tester or a TDS meter will be able to tell you whether or not give you an idea of the hardness of the water. Oops, I skipped a slide, sorry. The typical inspection process. So this is basically from feedback from some raters that participated in the pilot. Now, we anticipate that this inspection process will be done during the typical final rating inspection for a HERS rating. And basically, this is what the raters generally felt like was a pretty efficient way to do the inspection. So you come into the home, put the dye tablets into the toilets, and then you go and verify the flow rates of your fixtures, record the make and model number of the dishwasher as well as the clothes washer, assuming they're installed. And if there's a water softener system installed, record the information off of that. Then you go back and check the toilet, see if there's any leaks, flush the toilets to clear the dye, verify the flush rates that are stamped on the toilets, and then check the whole house water pressure. You can also, checking the water pressure is optional. You could obtain documentation from the builder or the water supplier, which says that the water pressure is not going to exceed 90 psi. I believe 90 psi is the above that, and you will start to receive some penalty within the HERS H2O score for high water pressure. And now, as I'm closing, kind of wrapping this up, I want to talk a little bit about potential impact and more or less the ability of HERS H2O to scale and to scale quickly within the HERS rating infrastructure. So as many of you have probably heard, there's over 2 million, just over 2.4 million, more specifically, HERS rated homes across the country. And 23% of all new homes in 2017 received a HERS rating, and many of them are in the areas that have expressed a particular interest in HERS H2O, which is in the Southwest, where they do tend to have more water scarcity issues and drought. Currently, there's over 1,900 active RESNET certified HERS raters. In total, there's been over 5,000 raters that have been certified, and there's just under 2,000 that are maintaining that certification and are actively doing ratings now. So the infrastructure is there to be able to quickly scale up, and you know, as I mentioned at the beginning, this was the idea behind HERS H2O was something that could be easily added to a HERS rating. So once we get the HERS H2O training, the online training off the ground, we're expecting that the HERS H2O training will be all online, and it'll be a 3-hour or less training. We're just about to sign the contract to have that developed, and we expect it to be completed in September. So it'll go on to the RESNET online training portal, and we'll be able to get those HERS raters that are interested in providing HERS H2O ratings up to speed and certified to do those ratings. We also have a network of rating field inspectors. This is actually one of probably the fastest growing certification that RESNET has. They're just a couple of years ago, there was about 500, and we're up over 800 rating field inspectors. And the rating field inspector has to work under a certified HERS rater, but they're typically that person who's going to be in the field doing, for HERS ratings, doing your pre-drywall inspections and your building envelope leakage test, your duct leakage test, and we expect that they would also add in the HERS H2O inspection within that. So the infrastructure is there to be able to quickly scale up and start adding HERS H2O ratings as an additional service that raters can offer to builders. And then finally, if you are interested in staying up to date on RESNET's water efficiency work, you can send me an email. This is my email address. We will provide you with periodic updates, typically not more than once or twice a month. You'll also receive notices of public comments, public comment periods for the draft standard, as well as any webinars that we do. And we also provide a water update newsletter that comes out either every month or every other month, depending on what we have to report. That will also provide just a status update on everything that RESNET's doing related to water efficiency. And with that, I will take questions.
Great. Yeah, thanks, Ryan. We've got plenty of questions pouring in, and we do have some more questions right now as well. And before we get to those, I want to say a huge thanks to our top tier sponsors who allow us to do what we do. Shrinergy for on the go or in your house or office. Backup solar power battery systems for not if, but when the grid fails. T-Stud structurally insulated framing systems for saving money and energy behind the walls. And Mitsubishi Electric for getting to net zero with all electric air source heat pump systems. Thanks to them, thanks to our members, our board of directors, volunteers who allow us to do what we do. And then real quick, for those of you wanting to pick up your continuing ed, just make sure to take that survey that pops up at the end, or the one that comes through your email, same survey. For those of you listening to this on the demand in the future, make sure to take that 10 question quiz with an 80% passing rate, and then follow the instructions whether you're on USGBC channel or on our YouTube channel. And if you are on YouTube, go ahead and just click down the YouTube tab there while you're watching the video. And then on the left there, go click Show More. Pops open the description, and from there you can go ahead and grab the quiz and then start taking that quiz while you're waiting. So yeah, let me get into some of these questions that had come up. One of them, or two of them, I'm going to kind of merge together, and that was, is structural water waste, so that is water wasted before hot water is detected at the fixture, based on a measurement of water volume before water temperature reaches, say, 100 degrees. And then in junction with that question, how could point source on demand small water heaters play into that?
Yep. So the standard does take into account the distance from the hot water heater to the furthest fixture, and there is actually within the calculation spreadsheet, there's, as well as the inspection guidance document, it explains how to calculate that distance. because in many cases it's kind of estimated based on number of stories in the home, or the horizontal distance from the hot water heater to the furthest fixture. So you can, for structured plumbing where you are reducing the amount of water volume or length from your hot water heater to your hot water using fixtures, yeah, you can get credit within the HERS index, HERS H2O index for that.
Are in-ground and above-ground pools rated the same?
As far as I know, they are. So the pools, all for pool and spa, all it is an indicator. There's not, the data is not really granular enough that we can say, you know, if you have this specific type of pool, you're going to use this much more water. It's really it's a more general number. So if what the data does show is that if you do have a pool or a spa, you will use more water. And so it's basically just an indicator that adjusts for the fact that it adjusts your water usage upward if you do have pool or spa on the property.
Does outdoor water use take into account that some zones may run for shorter durations of time than other zones, and some zones may run on fewer days than other zones?
It does. No, I don't believe so. I believe it only takes into account the entire water flow for all zones, and not the actual schedule at which the irrigation system is going to run.
So speaking of outdoor zones, or could there be, or is there any opportunity to utilize the EPA's WaterSense water budget tool for this program?
I'm not sure if there's a direct relation to that at this point. We can share. I don't think that we take into account the water budget tool within the index, but we can share the calculation spreadsheet. If anyone's interested, they can always shoot me an email. I can share the spreadsheet.
Well, that was going to be another one of my questions, is that, you know, a lot of times we get builders, designers who kind of want to take a look at all this stuff. Maybe they're really heavily do-it-yourself, want to kind of pre-design their project and then see if it's worth hiring a rater to start rating it. So will there be, like you said, opportunities to kind of get some of these numbers down themselves, either just in the pilot or also as an ongoing opportunity without having to be a full-fledged HERS rater?
Yeah, so now is that time to take advantage of the fact that you can play around with the calculation spreadsheet. You don't have to be a HERS rater to access it. I can share it with anyone who's interested in seeing how HERS H2O you could take it now and go ahead and rate, a builder could go ahead and rate one of the homes that they're building or that they've already built and see how it scores, and play around with the spreadsheet and see what they can do to reduce their water usage and their HERS H2O score. So now is a great time to do that. Once we move to software, we will probably stop sharing the spreadsheet, and you'll have to be a certified rater in order to get access to the RESNET accredited software.
And multifamily, you mentioned not yet, but is there a plan to be able to incorporate multifamily in the same way that, you know, HERS does?
Yes, we've had many requests to incorporate multifamily, and I do believe that a study was published within the last 6 months or so that does look a little more in depth at water use in multifamily buildings. So we are hoping that we can use the data from that to begin to develop a multifamily component to this.
And then I was, I understand the number of bedrooms kind of helping estimate the number of people, which significantly impacts the amount of water being used. But I was kind of wondering how square footage, from a technical standpoint, ties the square footage of the house, not the yard, ties into actual water usage.
It doesn't. So I don't think that square footage has much impact on water use as compared to the number of bedrooms and number of bathrooms. So I wouldn't say that the square footage has a direct impact. We do capture it as a data point, but one that rolls over from a HERS rating. So I don't believe the data shows that actual square footage of the home has much impact on water use, but square footage of the landscape area does.
So, obviously on the energy side, the HERS index rating, a rating of 0, getting very trendy now, getting to a net zero home. Obviously you've set up HERS H2O to kind of follow that same pathway with a 100 to 0. So I suspect as net zero energy gets really trendy, net zero water is going to become the next topic and the thing that people start going after. So I saw you kind of get some numbers driven all the way down to the 50s. But what's being discussed to get further lower than that and drive it all the way down to 0?
Yeah, so that's really where rainwater and gray water and possibly reclaimed water come into play, because that's really, that's kind of that's our HERS H2O equivalent of renewable energy in the HERS index, and that's what I expect will be what enables a builder to get to 0 or very close to 0 within the HERS H2O index. And I expect that it won't be incorporated when we publish the first version of the standard, but I expect that maybe in a year or so we will have an addendum to standard 1101, which will incorporate usage for gray water and rainwater.
Now I know some programs take a look at groundwater, and I'm wondering how I saw you had mentioned hard water and a few other things, but how would this take into account groundwater and counting it towards, not using water it potentially is, put back into the aquifer at the same rate and the same quality?
It doesn't. So it looks at kind of regardless of where your water's coming from, it's looking at it from an asset standpoint in terms of the home. It's going to use a certain amount of water, and at this point it doesn't matter if that's coming from well water or city water, or potentially an entire house that's running on rainwater, because at this point it doesn't take into account anything beyond the home site. It's just making the assumption that it's whatever amount of water you're using. It doesn't matter the source at this point.
Well, great, Ryan. I don't see any other questions here, so I really appreciate your time, and thanks to RESNET for having you out. And just real quick, where can people get more information or access to those spreadsheets if they'd like to learn more?
Yeah, the easiest way is just going to be to send me an email, and I will reply and attach the spreadsheets or any of the standard or the inspection checklists or guidance documents, any of that. Easiest through me. We do have some on the website, but I think we have not yet included the most updated version. So you're best to send me an email, and I can get you the most current version.
Okay, great. Well, thanks for your time, and have a great week, everyone. Goodbye.
Yep. Thanks, Brett. Bye.